you're all here. As Sharon said, I'm the PhD student in the Computational Social Science group of Professor Dirk Helbing. And if you're like an ETH student or an international student, you want to write a master's thesis with us or a bachelor's thesis like in these kind of topics, just approach me and we can talk about it. So I'm going to talk about understanding blockchain better with blocksonomy, and that's the content of the talk. So I will give you bits of introduction to distributed ledgers. I will talk what it is, how a DLT system looks like, what is crypto economics, some applications and some delusions when it comes to this technology. Then a little bit technical about the consensus, so at least you get an understanding how the proof of work at least works a little bit. And in the end, I tell you a bit about blocksonomy, like a website we develop. And because I'm the last person in front of you and in front to lunch, I will try to be quick. Yeah, let's start. So who heard about blockchain before this session? And who heard about distributed ledgers before Nick mentioned them? And who knows what a smart contract is? Okay, cool. So already like a good nice crowd. So like all these terms are kind of connected, and the stack looks more or less like this. So we have these term or like these type of objects which are called distributed ledgers. As Dirk said, it's more or less like a decentralized database. And one type of instance of these decentralized databases is a blockchain. But as Nick mentioned, there are also other types like hash graphs and directed acyclic graphs, for example. One application or like one instance of this blockchain, like what it can be used for are currencies, but another type are also smart contracts. I will talk about it in a second. And one use, like, or one type of these currencies are actually Bitcoin. So many people heard about it, but there are also other type of currencies. So just to get the terminology clear. Okay, so coming to the distributed ledger system, that's like how such a system looks like. And I will now walk you through this picture. A distributed ledger is a ledger. So it comes from the stock exchange, and it means basically every transaction which is happening is like noted down, written to a ledger. And because like in this world we are moving, these ledgers are distributed on many different PCs. These ledgers are called distributed ledgers. And one type of these ledgers, as I said, are blockchain ledgers. Then we have another part in this system which is called the consensus network. So these are single nodes which actually take care about the work, like the writing to the distributed ledger. So these nodes in the consensus network, they talk with each other, and if they agree, they write to the distributed ledger. And then of course we also have actors in these systems which interact with these ledgers. So for example, we can have a person like in front of his PC, and he wants to send a Bitcoin to someone. So he makes action, he clicks a button on his PC and wants to send this Bitcoin. This claim of this action is sent to the consensus network, and they talk with each other. Does he have a Bitcoin? Is he allowed to send it? Does he have a private key which is fitting? And if they agree, hey, everything fits, and they're doing some work, they actually write to the distributed ledger, and they note this transaction of value as a transaction to the distributed ledger. Okay, so that's basically was the first application. This is basically what Bitcoin is doing. But now one can go a step further and think actually about what happens if instead of a transaction we actually store code into these distributed ledgers. So not just transaction, not just sending, hey, I send to Bitcoin, but full Turing complete code. And this actually makes such a distributed ledger to a computer. Yeah, so you can put code inside, and when you start executing it, these distributed ledgers can turn to a computer. And this was basically what Ethereum did as one of the first big projects which actually used the Turing complete distributed ledger. And yeah, you will see more of Ethereum later, I guess. Okay, and in this context of distributed ledger technology systems, one always hears this aspect of trust. So what are we actually trusting in this setup? And what we're trusting is actually that this process is correct, that basically these nodes and miners, they don't collude, that there's some incentives, that they're truthful, that they're writing the right entries to distributed ledger, that actually entries in this distributed ledger cannot be modified retrospectively, and all of these design parameters, and there are many inside of them, basically we trust this. And yeah, the question is if we always can do this, and there are different outlined. But this is like where crypto economics comes inside. So the first take on crypto economics in this space is basically designing the system in a way that it can be trusted. So finding the right parameters of your application, of your tool, that people can trust it. But the question is trust everything in the setup, or can we do more? And actually, there's a second take on these crypto economics, and for this we developed in our group a conceptual view of these distributed ledger systems. And again, we have our actor, we have our computational nodes, we have distributed ledger, and now there comes this new thing inside, these tokens, like single units of value. And what we said, basically, we have these four components. So we have an action component where the actors live inside, we have a consensus component where the consensus network is inside, we have a distributed ledger component and a token component. And how do these components act with each other? And they interact all together. So we have actors in this action component, and I can make an action. I can click a button. Then I send this claim to the network. Writers, they're taking this claim, and after deciding it's correct, they write it as a transaction to the distributed ledger. And then in some cases of these blockchain systems or distributed ledger systems, actually a new token gets created, which is awarded to the one who actually wrote to the distributed ledger, so that he does the work. It's kind of incentive system. And now is the question, why should this consensus node do this work? Why should he work? This token needs to have some kind of value to this user. And we are saying that these values of these tokens can actually lie in these four components. So a token can actually give you access to voting rights. It can maybe be backed up by some commodities. Maybe it gives you access to some smart contracts, to some code, or maybe backed up by a different currency. And this is actually what makes the writer do the work, because he knows he will get the token. And like for one example, in the case of Ethereum, which I just mentioned briefly before, actually an actor can write a piece of smart contract, so I can do this work. I click a button, it's sent to the consensus network, they write it to the distributed ledger, then a new token gets automatically mined, like an Ether token, which is awarded to the writer. And actually this token has value because in order to access the smart contract again, to execute the code on the chain, you need this token. So basically actors, they now go to the miner and they buy the tokens from the miners in order to interact with the distributed ledger. And that's kind of an incentive system, ecosystem, which is working. Yeah. And now what our group is basically doing, we're trying to bring this concept one step further. What is if we're not only incentivizing the writer, what is if actually a token, when it gets mined, is also a part of it, is getting attributed to the one who did the action. So how could this look like? So for example, hey, we want to incentivize planting of trees, or maybe sharing power, or something else. Actually, the act of doing it creates a new token, maybe. And this could lead to new incentive systems. Okay, this is the second type, the second take on this crypto economics, because actually, why should the actor do this work? And here comes everything about crypto economics, basically designing the token in a way that actually users want to have it. And in our architecture, we basically say tokens, they have inherent properties, they can be capped or uncapped. We have this mode of creation. How do they get created? Through incentivizing an action, or maybe they're pre-mined, they're all existing beforehand, and what actually gives value to these tokens. And then one can go one step further and say, hey, maybe we have a project where we have several tokens inside, and what are the interactions between several tokens? And this would be the third take on crypto economics. Okay, cool. So distributed ledgers are about trust. And what does it have for implication? So basically, when we have Alice and Bob, in our current world, they always need to interact through a trusted intermediary. Yeah, and the idea is now to use a distributed ledger to replace this trusted intermediary. And what could this trusted intermediary be? So for example, we saw with Bitcoin that actually for a transaction of value, we don't need banks. Of course, they still have other functions, but for this transaction of value, we could use such a distributed ledger. Then one could take this a step further. So currently we have a lot of companies which are claiming to be some kind of a sharing economy, like for example, Airbnb and Uber. But in this setup, we're still trusting someone. Yeah? So when I want to rent a flat, I go to Airbnb and I'm trusting Airbnb that they're using the right code, that they're not cheating me, that they're not taking too much money, that they're giving me the right person to connect, like all of these things. And one could actually put this a step further and say, hey, what is if we take all this code and put it onto a blockchain, like on Ethereum, where you have these smart contracts, you could program it. Then it could be a real decentralized Airbnb or Uber. And some people are taking this further to governance systems, legal systems, and thinking about such approaches. And these could be some of these implications. This sounds all very futuristic and positive, but of course, they're also not everything is as easy as it seems. And often one hears that actually these distributed ledgers, that they're about anonymity. Yeah, so that in Bitcoin you stay anonymous, but this is actually a delusion. Because, for example, if you're like a user and you want to buy something, and you're actually buying something at Amazon, and you're making this transaction of Bitcoins, your transaction gets locked in this distributed ledger. Okay? And what does it mean? It's public, so everyone can see to whom you transacted. And when you now have an account at Amazon, Amazon can go to the distributed ledger and see, this guy owns this address, and then they can see, oh, where else did he send Bitcoins? Yeah, to this person, to that person. And then actually Amazon knows whatever you do, yeah, where you send your tokens. And when you know things, maybe Amazon is colluding with the US government or like these kind of things, and it becomes very transparent actually what your financial transactions are. So there are some blockchain systems out there which actually try to change this. So they are encrypting the distributed ledger, they are mixing up the transactions, they're called privacy coins, like Zcash is one of them. Okay, the second thing, decentralized. So we're always talking about decentralized distributed systems and we're trusting them. But for example, in the case of Bitcoin, actually the big majority of those consensus nodes, they are in China. And when we think that China is not so democratic, it's a question how much influence do they have on the network. Even if you have the majority, it's very hard to change the entries in such a distributed ledger, but you can run some kind of attacks and you can prevent some transaction to be entered into the blockchain, these kind of things. And then there's other systems like Ripple, for example, where this consensus network is restricted. Not everyone can join it, which makes it, again, much more centralized than it is. And then in the end, you're always trusting someone, so you're trusting the programmers who are programming it. There are always bugs in the code, so one should also question if we really should put everything into these systems. For example, voting, should it really be inside of such a system which potentially can be hacked? And yeah, you can fall. Okay. Yeah, very quickly. Okay, now we come to the consensus. This will be a little bit technical, but just very briefly, but I think like if you're part of such a thing, you should at least have a small feeling how like the consensus works. And the consensus, just to remember, is actually this act of writing to the distributed ledger. Okay? It's basically the mechanism of writing entries to this distributed ledger. And for this to understand, we need to know what the hash function is. And the hash function is actually something which is easy to compute in the one way, but very hard to compute in the other way. That's the basic idea. And if we have something like this, for example, we have a piece of text like Fox, we put into the hash function, a number comes out. So the idea is that this direction is very easy, but when you see the number, you don't know actually what the text was. Yeah, so it's very hard to reverse it. And such function exists. And yeah, so that's the first ingredient to these consensus mechanisms. The second one is actually the block structure of these blockchains. So like this is just a blockchain, not a DAG, but let's keep it simple. So we have a blockchain, and you actually have such a tree. And in the leaves of this tree, you have all the transactions inside of this block. And actually such a transaction, they link to the distributed ledger. Okay, it's one entry, the distributed ledger, and the full block is kind of a bigger piece inside of the distributed ledger. And now these blocks, they are linked with each other. But how are they linked? So actually each block has the hash of the previous block inside of its block. So we're taking the old block as input, we generate a hash which is stored in the next block. Okay, and that's the way how they are linked. Because like the hash is more or less unique, so you know if I have the block 10 and I have the block 11, I can show that actually the block was before block 11, because the hash which block 10 is generating is the one which is stored in block 11. Okay, and now comes like the heart of the first type of blockchain systems, like these proof of work systems, which also Bitcoin is using, the proof of work. So what is it? And actually what the consensus network is about, they are calculating something. So they are calculating these nonce. And why are they calculating it? So what they're doing, they're calculating these nonce, they're putting it into a block, they're calculating the hash which will be later stored in the next block, and they say this hash has to be smaller than a specific number. And as we know, it's very hard in a hash function to go back. So having this number is not so clear how the block should look like. So you have to try it out. So what basically the consensus network is doing, they're calculating all the time, they're changing these nonce, they're putting 1, 2, 3, 4, 5, they do it like crazy, they put a lot of computing power into it, they calculate, until they find a hash which is smaller than a specific number, which is hard. And when they find it, they say, hey, we have a new block, that's a block. The others, they can check it very easily, because this calculation is very easy, as soon as you have found it. And then it goes on, you're trying to find the next block. And yeah, that's the proof. That's the reason proof of work. Okay, so this was the most technical as it gets today, and now a very, very brief closure. So we heard a lot of terms, and the thing is, the design space actually in these blockchain systems, these ledger systems, is pretty big. You can have restricted consensus, you can have private distributed ledgers. What is actually the design space of these ledgers? And we wrote a paper like decrypting distributed ledger design, which actually takes this conceptual architecture and develop the taxonomy. Yeah, so in this taxonomy, you can basically distinguish between Bitcoin, Ethereum, or some other blockchains. And I'm just very quickly, I will not go into detail, but for example, in the action component, one could say, hey, actually, how is the actor permission in the system? Can everyone do transaction, or do I need a permission? Can be public and restricted, and for example, in the Ethereum case, it's public, in the Ripple case, it's restricted. Or for example, who can actually read entries in this distributed ledger? You can say it's public, restricted. Or you go to the consensus and you say, hey, what type of proof is actually needed? Yeah? In the Bitcoin case, you need proof of work. In the EOS system, it's proof of stake. Or who has the right permission? Who can write? Who can be a miner? Like these kind of things. In the distributed ledger, we heard the different types of distributed ledger. We have blockchains, we have DAGs. For example, Ethereum has a blockchain, IOTA has a DAG. And some of these distributed ledgers, they are Turing complete. So Ethereum is Turing complete, IOTA isn't. And also in the token, we saw that the token can be capped or uncapped as a supply. You could incentivize actually how is the token coming into existence, which is kind of the heart of our research, like how does it get created? Is it through the consensus, is it through the action, through both, through nothing? What is actually the underlying of this distributed ledger? And if you want to learn more about how these blockchain systems look like, we actually did a classification of 29 of these systems. We uploaded them, so it's still a very early alpha version, but you can check it out on www.blocksonomy.space and maybe get inspired also for your system. So you can really see what is the design space, which part in your system should be restricted, which should be public, where you want to have what. And that's all. Thanks, and if you have a question, please